Hi, welcome back. In the second part of the series, we're going to talk about and decide on our AI base class. It's an important decision to make as it does set the foundation for our overall design and future scalability of our system that we're working on. So let's take a look at the fundamental question we have to ask ourselves, which is where do we base our AI on? And drew this little chart. We could inherit from any of three basic classes. We could inherit at the very bottom off of our A actor class. So this would be the least expensive resource cost and also the least amount of capabilities that are available to us as a base class. Or we could base it on the pawn class, where the resource cost of a pawn is higher than the resource cost of an actor. Or we could base it on a character, which is higher cost than a pawn. So these are kind of stacked in the three most logical categories of basing our AI actor in game on either an actor, pawn, or character. And each of those has a corresponding resource cost associated with it. So it's important that we figure out which of those three that we choose from. Then once we decide whether it's actor, pawn, or character, we then have potentially another decision to make, which is, do we make the base class the standard Unreal class of actor, pawn, or character? Do we make it the modular pawn or modular character, which are two classes available in the plugin for modular characters? Or do we base them on the Lyra character or Lyra pawn? So, first decision we have to make is, are we going to build our system around an actor, a pawn, or a character? And then, based on that decision, if it's pawn or character, do we do it on pawn, modular pawn, or Lyra pawn, character, modular character, or Lyra character? We probably won't even consider this one. I just left it in here for completeness, but that is that class basically makes the ability system part of the character as opposed to the player state, which is what the default game mode is for the rest of them. So that's the decision we have to make. We're going to jump into the game. We actually have or the editor, sorry. We actually created a little project to test some performance testing so that we can see which of those three, how much performance are we giving up, which decision makes the most sense. So let's jump back into the editor. All right, so we're in the editor, and we've just created a new blank project for this test. So rather than having all of the distraction of the Lyra framework, we're really trying to test whether we want to standardize on an actor, a pawn, or a character for our AI. And so the best way to do that is to do a little bit of performance management and see if there's a material difference between the three different classes at the base of all of our in-game AI. So we created a blank third-person template. We took the floor and just stretched it out so we have some more room. And we're creating these basic actors. So the AI controller is absolutely empty. In fact, we probably didn't even need to create one, but it's simply a blueprint version of AI controller. Then we created a test actor off of the actor class, a test pawn off of, or sorry, a test pawn off the pawn class, and a test character off the character class. And all three of them are set up identical so that the only difference that we're measuring at this point is the difference between spawning and managing each of those three types. So they are very, very basic. There's no event graph at all. We created the class, added a skeletal mesh, put the mannequin mesh in, not even running a blueprint, an anim blueprint. We're just using an animation asset, so they're going to jog forward. So they basically all look identical to this. So the actor is simply that. Then if you do the exact same thing with a pawn, again, nothing in the graph. The difference is when we spawn it, we're going to give it an AI controller. So it's going to automatically get a controller attached to the pawn. Again, the controller is doing nothing. We're using the same skeletal mesh. We're using the same animation. And I should say on all of them, we disabled tick. So the actors themselves are not ticking. So the only difference really is the parent class and how the actor lives in the world. And then for the character, you end up with, you do get by default the collision sphere. So that is net new in a character and is unavoidable in a character. So the overhead of the collision sphere is there, and then the overhead of character movement component. This is automatically added for characters. However, the rest is the same. We're using the same animation. We're using the same skeletal mesh, and we have turned off. We have not turned off tick. Well, let's go ahead and turn off tick, but I don't think that matters. So we have all three set the same. Oops, my log file. Then we just created this simple, because this is not our final project, this is just a test thing. We created a very simple spawner. What the spawner is doing is it's waiting 5 seconds. Then it's going to spawn in our test actors. We're going to wait 5 seconds, and then we're going to despawn our test actors, and we're going to loop that over and over again. So this is simply to test, is there a performance impact of using any of those three classes? So for spawning, we are, I'm going over this quickly because you don't need to know all this. We're basically figuring out a position in the world and making a grid out of that, and then determining based on these switches whether we're going to spawn in an actor, spawn in a pawn, or spawn in a character. And then each of them have their own corresponding arrays, so that when we despawn and clear the array. So these are identical for all three. The logic we're using is these two bulls. If it's false and false, we use the actor. If it's true on the pawn, we use the pawn. If it's true on the character, we use the character. So again, it's just a simple class that will allow us to test spawning in a number. And we are going to spawn in 500 of each of them. I think that's all we need right now. Yeah, so we're going to run in 500 of these every 5 seconds. We're going to spawn them, and then we're going to despawn them. And we're using, as we talked about this earlier, we're using the spawn actor, which we said is expensive. The object pooler will help us with that. But for now, we're just going to spawn them in and destroy them. All right, so placing that spawner right here in this corner, we're going to do a couple of things. So we're going to call up our first, we're going to do a stat FPS. And what stat FPS does is in the upper right corner will give us our frames per second right here. All right, so we're running at 30 frames per second in the editor, not running the game. So there's one other command we're going to want to run right now, which is T max frames per second, because we're actually being capped at 30 frames per second, and we want to push that up. So I'm going to move T max frames per second up to 120. Oh, yeah, I'm on a different monitor. This is my 4K monitor. So we are running at full capacity right now in editor. When I have it on my smaller monitor, it jumps up into the 90s. milliseconds. But for this demonstration purposes, this will actually make it even more egregious. So the next thing we want to do is let's double check that we're going to spawn in the actors first. So we go into our outliner, our spawner, and we're saying no to both of those flags, which means we'll spawn actors. Okay. And I'm going to launch the game. Oh, wait, no, I want to do one more. I'm going to pull up from the console one more. So stat unit. So stat unit will break out, instead of frames per second, you'll see here the frame, game, draw, and GPU calls. Right? And so our frame is currently about 30 milliseconds. And the reason is our GPU is running about 30 milliseconds. So my graphic processor takes 30 milliseconds to draw this image that you see. So the way you think about frame is it's the highest of game, draw, and GPU. All three have to occur, and the frame is generally the highest. So our game thread, which is our CPU, is running at about 10 milliseconds. Our draw thread is running at about 12 to 13 or 14 milliseconds, but our GPU is taking 30 milliseconds, and that's because of the 4K monitor that I'm running on. So that results in 30 milliseconds overall, and then that converts to about 30 frames per second. So what we're going to do is we're going to launch the game, and then I'm going to press F8 and F11. And the reason I'm pressing F11 is you'll notice these numbers change when I go to full screen. So I don't want all of this editor rendering to influence with our test. Now I will pause here and say, because someone may be thinking it, you shouldn't do performance testing in editor. You should build your client and do your performance testing that way. For this simple test, that's not that important because we're going to see such a variety of results that it's not worth going through all that effort. But in general, as a rule, you do not want to be doing performance testing in editor for any real performance tuning, because you want to tune your game without the editor in the background. All right, so let's hit play. Okay, we're going to press F11 to go full screen, and you'll see our frame count bounce around a little bit. And then we're going to press F8 to eject out of our character. We're going to slide over here to where our spawner is. All right, so there are the 500. They'll be on screen for about 5 seconds, and then they're off. And so now if we kind of look at our frame rate, we see that we dropped to about 17 frames per second. And we see that the game thread is the one that's causing the slowdown. The game thread jumps up to about 50. All right, so the draw is a close second. The GPU is still running at about 30, but it's the game thread that then pushes our frame rate down to about 15. So I'll let it run one more time. Okay, so let's stop that and come out of full screen mode. And now let's bring in a pawn. We're changing that to be a pawn. And we're going to do the exact same test. We're going to start the game, press F11, press F8, slide our camera over here. So now we're spawning pawns. And if we look at our frame count and our game, so we're a little worse, right? We're almost 60 on our game thread, where we were in the 50s before. So there you see we're about 58, 59, 60, right? So when we're using the pawn, there is a performance delta from the actor to the pawn. Now let's look at the character. So for the F11, outliner, Let's enable the character. Same. All right. Press F11. Press F8. Move our character over here. Oops, I went too far. All right, now we see a dramatic change, right? Even my camera movement is being impacted. And so with the character, our game thread has tripled from our pawn. Our game thread has moved from about 60 milliseconds to 180. And our frame rates have dropped significantly. So what this says unequivocally, we don't want to use character. It is significantly worse than using pawn. And so the performance hit of spawning 500 characters is something we're just not going to be able to optimize around, right? It's just too resource intensive to draw. So if you think about it, we didn't see nearly as much of a difference between an actor and a pawn than we do with the character. So we're going to rule out character based on that test alone. All right, so now let's go back to being a pawn, because I want to show you one more thing. 11. Oh, no, still in game. There we go. All right, so clearly we're going to want to go back to the pawn. That's not what I wanted. Let's look at a couple more things. So we'll do F11. Oops, F8. So as I said, the pawn was more expensive, which is to be expected. You can see there it jumping into that 60 millisecond time frame. I want to do a couple more commands. So the first one I want to do is hit the tilde key to bring the command up. I'm going to do a stat game. And what this will do is in the middle of the screen, now this will affect our performance, but what it'll do in the middle of the screen is show you the pieces of the game thread that are spiking at various frames. So you can see the red bars that are elongating and then shrinking. You see there the red bar, world tick time, post tick component, and then they go back to 0 after they despawn. So this is showing you exactly on the game thread where are all those milliseconds going, right? And over half of them, I think, are in the world tick and tick. You can see there they're running up to about, almost 50 of it, and then they come back down to 0. So that stat game allows you to look into the game thread and see where in the game thread those stat groups, where the CPU is being utilized. All right, so we're going to turn that off. And then we're going to do one more thing, just for profiling perspectives. So what we're going to do is we're going to do a sort of a log file. So we're going to do stat start file. And when we execute this command, it's going to start logging to an external file. All right, so I'm going to wait till they despawn. I'm going to start the file, and you can see that we're logging in the upper corner. Our folks come in, then they go away. And now we're going to do the same thing, but we're going to do stat stop file. And that's going to stop the logging file. Okay, so we've stopped logging. Now we're going to exit the game and go back into the editor. What I want to do now is pull up the session front end. So under Tools, Session Front End. Go to our Profiler tab. So in the Session Front End tool, the profiler allows you now to load that log file. And that log file is in your projects under saved profiling. You'll see an Unreal stats folder. And then this was yesterday. Here's today. This is the file. All right. So this is indicating that the log file is with the editor, as in here, the Pi session. So we're going to open that. And what it's going to do is basically process that file and give us a bunch of data. Now, I'm not going to spend a lot of time in here walking you through all this data because that's not the purpose. The purpose is to see, come on, baby. The purpose, I really need to make a view for this, is to see this graph. And as I scale out, so this graph, and you can see it here in the top, right? So if I were to sort of focus us, this, I'm just moving it. So here we're running on the game thread in red, and we have this spike, and then it's high, and then it drops back down, right? So this is when the AI are on screen. So we're running here on the game thread, that's this green line. We're running, and then you see this massive spike here. Let's see if I can get it on screen. This is the cost of spawning. So when we spawn into the world, that particular frame is a giant spike when all of them come in. That's why we're going to cache with the object pooler. The object pooler is trying to solve this spike right here so that it doesn't cost us nearly as much to spawn characters into the world. What we're going to be doing with the AI spawners is bringing this spike down. So this is the spawn, this is the despawn, and then this is while all the AI actors are operating in the world. And so what we're really going to try to do with our AI spawners is never have 500 active actors, but manage that number down by using the AI spawners. So this is 0. Obviously, we're never going to get to the 0 line. But our AI spawners, we're going to attempt to push this block down so it's closer here. So if we can get rid of the spikes with the object pooling here and here, and we can push this block down closer to baseline, we'll have a much smoother experience in our game, and we'll be able to manage through all of that. So those are the techniques. This is the rationale of why we do that. And so from these tests, we're going to go ahead with the pawn because it's a little more expensive than the actor, but there's a whole lot of benefits of having a pawn. So let me explain what I mean by what is the benefit of having a pawn is if I play with the pawn, pull this outliner, you'll see that, okay, all these AI controllers are automatically spawned. No, then I'll have to wait for the next cycle. Anything in yellow is being spawned in game. AI controllers. Come on, scroll faster. Probably should have had less of them. All right, we're going to scroll faster the other way. And test pawns. So I end up with 2 actors when I create that. Now, I don't have to have 2 actors. So one of the things that we can do is for certain pawns, we can say, look, I don't want you to have an AI controller, which puts it much closer to an actor, right? So the overhead that we're seeing for the pawn is because we're spawning the pawn and the AI controller. But we don't have to spawn the AI controller. We could just spawn the pawn. And by not adding the AI controller, we're essentially making a pawn very close to an actor. And so in that scenario, when we hit play and we wait our 5-second interval, right, we're just getting the pawns. We're not getting the controllers. And so we do have control over whether or not that AI controller gets added. And centering our design on a pawn then makes things that much simpler, uh, because we get the benefits of an actor just by disabling the AI controller, but we also get all the benefits of being able to have an AI controller on certain pawns that might need more AI capabilities. So for those reasons, we're going to be using the pawn as our base class for our AI in the world. Okay, so based on our tests, and we put the uh, consult commands here on screen so you can have them at your fingertips. So based on our performance testing, the answer is to use the pawn. As we saw, the actor and pawn delta wasn't that much different, but the pawn to character was a significant step up in resource cost. And so, therefore, the benefit of moving from actor to pawn outweighs the cost, but the benefit of moving from pawn to character does not outweigh the cost. And therefore, we're going to center our design around the pawn. And given that, we now have to decide which of the pawn classes do we want to use for our design. So a pawn being the basic out of the box standard Unreal class, which then the next one is the modular pawn. And if you look into the code of the modular pawn, really all it's doing is adding the gameplay framework component receiver, which is a way to allow a class to receive new gameplay font. So there's not a lot of cost delta to moving from the standard pawn to the modular pawn. This is literally the only code that you're adding into it, and it's on begin play, end play, and initialization. So it's really not going to run. It's not going to add any overhead to step up to the modular. So we would definitely do at least the modular pawn over the pawn. Then we have to look at the Lyra pawn. The Lyra pawn, which inherits from the modular pawn, but also adds in the team interface. So the Lyra pawn versus the modular pawn basically gives us the capability to assign a team to this AI actor in game. And that actually can be quite valuable, right? The ability to create factions, warring parties, AIs that attack AIs, or AIs that are friendly to you because they're on the same team. That's got some merit to it. And so as we look through the code of the Lyra pawn, there's nothing really in here that will give us a performance hit, because all of the added functionality is around adding them to a team and then being able to query what team they are on. So there's nothing in here. There's no code or logic that would create a performance problem for us. So the net answer is, okay, let's go ahead with the Lyra pawn because it gives us all the pawn capabilities and performance aspects of the pawn. It gives us all the modular attributes that the modular pawn gave us. And it gives us team capabilities, which could be useful in game design. So we're going to go ahead and use the Lyra pawn as the base of our character. And we're going to go ahead and create a new C++ class, calling it AI pawn, which we will then inherit from Lyra pawn. So we're now going to have three classes at the end of this video. We'll have the AI spawner, we'll have the AI pawn, and we'll have the AI spawner subsystem. So those three C++ classes will form the foundation of the rest of this video series. So there's one more decision we need to think about before we start writing a bunch of code. And that is, how do we divide up the responsibilities between these three classes, right? So the object pool or the subsystem, the spawner, or the actual AI pawn. And we wrote a couple of things down here kind of share and talk about, which is if we think about those three as part of an overarching system, then there's certain things that each of them are good at. And so we're going to want to center our code in the class that makes the most sense. And so starting with the object pool or the spawner subsystem, we need to be able to manage all of the reusability of the classes. And so its primary job will be to manage the reusability of the various pawns throughout the game lifecycle. So that's its first job. The second job it'll have is it will do load balancing so that when you get into stressed situations, it can make some decisions around whether or not some capabilities are enabled or disabled in order to keep game performance up and running. And then the third thing it's responsible for is the reset of the AI. So as pawns are returned back to the pool is going to be responsible for wiping their past history out and resetting them to a neutral state. So if you think about it, I don't care which AI is coming back into the pool or which spawner has returned it. Inside the object pool, we will basically wipe that class back to a starting standpoint. In the middle of the spawner, we call it the overlord brain, right? And what do we mean by that? The overlord brain is responsible for the inter-pawn dynamics, right? So if you think about what happens when you play a game, let's say you move into a trash mob and there's 3 or 4 characters in that trash mob or 3 or 4 AI in that trash mob. What you don't want is them all attacking the player in unison simultaneously. And so the spawner's brain is responsible for, okay, AI number 1, you attack the player. AI number 2, you attack the player. AI number 3, you retreat. And so the overarching mechanics of how the multiple AIs work around the spawner will be handled by the spawner itself. It will make the decisions of the collective group, right? And it's important because you don't want every AI just like doing the exact same thing, right? Because if you left it up to the AIs themselves, they would likely draw the same conclusions in the same situations. If the player is here, do this. If the player is there, do that. That will get repetitive and it'll show in gameplay. So you need this overarching construct to say, here's how I want to orchestrate the various interactions. It's also responsible for tracking the AI states and where each AI is. What, are they dead? Are they alive? Are they attacking? Are they fleeing? We'll be responsible of the spawner to track all of that. In a non-combat scenario, they're responsible for the choreographing. So if there's a scene playing out in game between 2 or 3 actors that are talking to each other, they'll be responsible for, AI 1 say your dialogue, AI 2 say your dialogue, and back and forth. They'll be responsible for when we deactivate or activate AI for performance reasons. And they will be responsible for reinitializing an AI to its prior state. So if you look at these last 2 in the object pool and the spawner is going to get back an AI that was kind of in the middle of doing something. Its job is to wipe out whatever it was doing. The spawner is going to get a blank AI, and its job will be to reinitialize it to the state that it wants it to be in, right? And so we split this across the object pooler and the spawner because in those 2 scenarios, we want the AI pawn to be transferred back and forth, right? So I may have sent back pawn A and I may have got back pawn B, and therefore this is why you split the reset and the reinitialize between these 2 classes. And then the AI pawn is kind of responsible for everything that's individual about that AI pawn, right? Their individual attack pattern, or what we call their brain or their behavior tree, as we're going to get into it. What skills and abilities they have will be their responsibility. Any movement that we issue, the pawn will navigate around the world. If it's an interactable pawn, like we can click on it for a vendor or a quest or a bank, they'll be responsible for handling that. And then, of course, they'll be responsible for any of their own uh, animations, as well as particle effects, etc. I mean, the visual aspects. So that's how we're going to divide the work up. We've now done enough level setting and thinking and design that we can jump into coding in the next chapter. So hopefully this has been helpful in getting you guys to think about how we're going to design these, and then we're going to start jumping in and let's write some code in the next video. Thanks for watching.